Okay, so in the next lecture we're going to prove the Banach fixed point theorem, which is basically the contraction mapping principle. So first of all, we're going to make a statement regarding that, and then we're going to review some important definitions. Okay, so the contraction mapping principle says that suppose that X is a complete metric space, and suppose that the mapping T from the set X to itself, that is T is a self-map, is a contraction. Then the map T from X to itself has exactly one fixed point. Okay. So let us review a definition of what it means to say a mapping is a contraction. So here we assume that X and Y are two metric spaces. So a mapping from X to Y is said to be a contraction if there is a positive constant C less than 1, such that the ordinary distance between T of X and T of Y is less than or equal to C times the ordinary distance between X and Y for all points X and Y in X. Note that if C is not in the half open interval 0, 1, then the mapping is said to be Lipschitz. Okay, so now let us give a definition of a fixed point. So here, let X be a metric space. A point X is called a fixed point of the mapping T from X to itself. That is basically T is a self-map, provided that T of X is equal to X. So let us consider some examples. Suppose that X is a set of real numbers, and we define the self-map by T of X is equal to X plus 1. Then we see that T has no fixed point. The reason for that is basically the equation X plus 1 equals X has no solution. Now, finally, let's consider the following example. Suppose the function f from the closed interval ab to r is continuous, and that the image f of ab is contained in ab. Then the function f from ab to a set of real numbers has a fixed point. To see this, note that because the image f of ab is contained in the closed interval ab, that means f of a has to be greater than or equal to a, and f of b has to be less than or equal to b. So if we define the function g of x equals f of x minus x, then we see that g of a is going to be greater than or equal to 0, and then g of b is going to be less than or equal to 0. So we can apply the intermediate value theorem, which basically says that there is going to be some real number between a and b, call it x of 0, such that g of x of 0 is equal to 0. But remember, g of x is equal to f of x minus x. So that means basically f of x of 0 minus x of 0 is going to be equal to 0, which means f of x of 0 is going to be equal to x of 0. So basically x of 0 is a fixed point of the mapping f.